Good morning and welcome to week 7 notes. This is going to be notes for module 1. So notes, module 1, topic 2, lesson 2. Okay. All right, so today we are going to focus, these notes are going to focus on properties of quadrilaterals. We're going to determine different properties of quadrilaterals, or at least show you things that probably you already are familiar with, but we're going to prove it with the circles, because there are some things about circles that we do know. We do know that diameters are certain properties of diameters. We know that radii inside circles are equal. So there are just some properties about circles that we know, and they can help us prove stuff about quadrilaterals. Okay. All right, so, and also in this one, you will need to have a ruler. We're going to be doing some measuring. And you will need a compass because we need to construct a circle. But if you notice in these blue little notes here, about halfway or right by here, for number 1, it tells us we're going to be constructing perpendicular bisectors. We're going to be using patty paper, and we're not going to do that. That, I think, actually kind of makes it get a little bit messier, as well as take a little bit longer than what we really need to do. So we're just going to use our ruler and do most of our drawings. We're not actually going to be doing real constructions on this in these notes today. So we just need a ruler for having a straight edge and being able to measure some stuff. Okay, so we're going to start off here. So we're going to kind of skip the first couple of bullets on the blue part, and we need to draw a diameter DE of the inner circle. So these are concentric circles. They both have a center of A. They've already drawn the diameter of the larger circle, which is BC, and now we need to draw the diameter DE of the inner so that it's not perpendicular and it's not coincident. Coincidence means just like it says in the definition there, on top of each other. So we just need to draw, and I'm going to keep this one black, I think, so that we keep the diameters, or the diameters. Okay, so you can pick wherever you want to do it. It just makes sure it goes through point A, and all you're doing is drawing the diameter of the inner circle. Okay, and then we need to label it DE. So we're going to go D and E here. Then the next bullet in the blue says connect the endpoints. Okay, so I need to connect the endpoints, and here I want to do a different color so that it just shows up a little bit better. Okay, so I'm just going to connect the endpoints here of B to D, and I'm going to connect the endpoints of D to C, and then C to E, and E to B. So go ahead and use your ruler and connect your endpoints there of those. And then it's going to ask us some questions about this. Well, again, remember we have BC, that's the diameter of the larger circle, and DE, that's the diameter of the smaller circle. So even though we have concentric circles that have the same center, we know that BC is not equal to DE. So we know that BC is not equal or not congruent to DE. So we know that those two diameters of the circle are not equal. Now, BC and DE are also known as, if we're looking at the quadrilaterals, so DE and BC are called diagonals of the quadrilateral. We're not sure exactly what that quadrilateral is right now, what type it is, what special one, but they are considered diagonals. They are line segments that connect vertices of a polygon, in this case a quadrilateral, that are non-adjacent to each other, meaning they're not right next to each other. So there is a line that's connecting CE. Those two vertices or points on the quadrilateral are adjacent. They are next to each other. That's the side of the quadrilateral. But C and B are points or corners, vertices of the quadrilateral that are non-adjacent. So DE and BC are diagonals. So we know that in whatever this quadrilateral is, we know that the diagonals of this quadrilateral are not equal. Now, the other thing that we know is that A is the center of the circle, okay, of both circles. So that means the length of AE and let me move it back up here a little bit. We know the length of AE and AD are equal to each other because they're both radii. And we know the length of AC and AB are both equal to each other because they are also radii. So a couple other things that we know about this is that AB is equal to, and I should put line segments over these, AB and AC are equal to each other, the measure of them, and AE and AD are equal to each other because these are all radii of the circle, the inner circle as well as the outer circle, the concentric circles. Okay, so we know that those things are equal, but that also tells us that the diagonals bisect each other. So again, whatever quadrilateral this is, we know that the diagonals bisect each other. Bisect, again, means cut in half, or cut into equal parts. So they cut in half. All right, so the diagonal of DE cuts the diagonal BC into two equal parts, and the diagonal BC cuts DE into two equal parts. We know that because they're radii of the circles. Okay, all right, so okay, bunch of stuff that we know about the diagonals. Now, they're going to ask you to use a ruler to measure the lengths of the sides. So we're not talking about the diagonals now, so we're measuring the sides. So go ahead and take your ruler, measure BD, DC, CE, and BE. Okay, so I got about 4.5. You may have 4.4, 4.3 centimeters. Oh, I should have told you to say, yeah, measuring in centimeters. If you measured in inches, centimeters is going to be a little bit easier to measure in with this. Okay, and this length here, about 2.3 centimeters. This one here, about 4.5 centimeters. And again, you could be off a little bit. You could have got 2.2, 2.4, 2.1, 2.5. But the key thing is that hopefully the length of BE is the same as the length of DC, and the length of EC is the same as the length of BD, or pretty close. Okay, and you're going to be measuring in centimeters. All the measurements that we're going to do are in centimeters because we can put them with decimals and be able to go down there. All right, so we notice that, I have to scroll down a little bit here. We know that BE, Okay, BE is equal to DC, and BD, there we go, is equal to EC. So basically, opposite sides are equal. And these all should have line segments above them. Okay, but we also notice that not all sides are equal. So we can kind of throw out a couple of our quadrilaterals. We know that squares have all sides that are equal, and we know that rhombuses all have all sides that are equal. So we can kind of throw those out. So now we've kind of pared it down to rectangles and parallelograms. Okay. Now, it asks us to use a protractor. We're not going to get into using a protractor. We're just going to go through, and I'm just going to tell you what the measurements are of the angles. So this angle here is about 43 degrees. This angle here, when measured, is about 130, should be 137. Sorry, I wrote that wrong. There we go. And 137 degrees. And if you measured it, you might be getting a little bit different than what I did. Should be 43 degrees, and then this one up here is about 137. Okay. So again, what do we notice? Well, we notice that opposite angles are equal in measure. So we know that angle E is equal to angle D, and we know that angle B is equal to angle C. So opposite angles equal. Opposite angles are equal. We notice that they're not 90 degrees, so they're not right angles. The other thing is that we notice that, and I'm kind of running out of room here a little bit, okay, is that when we add, so, and I'll put it over here, when we add angle E plus angle B, it adds up to 180. And when we add angle, so I'm kind of looking here, so I'm going to scroll back up. So when we add E, 137, to angle B, 43, that adds up to 180. When we add B to D, 180. D to C, 180. So that means consecutive angles. Okay, and so let me get these written down here. So B to D, E to B, B to D is equal to 180 degrees. Angle D to C equal to 180 degrees. And angle C to E equal to 180. So this means that consecutive angles, angles that are right next to each other, are supplementary. Meaning they add to 180 degrees. Okay. All right, so if we have angles here, and I'll move it back down here in a minute. If we have angles, opposite angles that are equal, all right, what do we know about BE and DC? Well, we know that BE is parallel to DC. Okay. And we know that BD is parallel to EC. So we have not 90 degrees, not 4 equal sides, so that basically leaves us down with a parallelogram. So we know the properties in a parallelogram. We know that not all sides are equal. We know a parallelogram doesn't have 90-degree angles. We know opposite angles are equal in a parallelogram. We know opposite sides are equal in a parallelogram. We know consecutive angles are supplementary. And we know that the diagonals bisect each other. So lots of different little properties that we know inside a parallelogram. So again, consecutive angles are supplementary. We know that opposite angles are equal. We know not all sides are equal. We know that opposite sides are parallel and that the diagonals bisect each other. So basically here, opposite sides are parallel. So these are all properties that we know about a parallelogram. Okay. All right, so let's move on. Okay, next page. We're now on page 130. Okay, we need to draw a quadrilateral. Okay, and again, they talk to us B, F, C, G. Tell us to use this patty paper and all this sort of stuff. So, well, we kind of already have, okay, the diagonals, all right, or the diameters of the larger circle and the smaller circle already drawn. They did it kind of with the perpendicular bisectors, so all I'm going to do here is kind of use what they have given us, and I'm going to label this point here F, and I'm going to label this point here G, okay? And I'm just going to use that as my diameter of the inner circle. So now I just need to connect again. They ask us to connect the diameters. So I'm going to connect the diameters of B to F, the endpoints of the diameters, F to C, C to G, and G to B. So just take your ruler and connect the endpoints there. Now they tell us that FG is perpendicular to BC. So what do we know about, to answer part A, what do we know about BC and FG? Well, we know that BC is perpendicular to FG. Okay, perpendicular means that it meets at a 90-degree angle. Okay. And again, because the one is the diameter of the smaller circle and one is the diameter of the larger circle, we know that BC is not equal to FG. All right, so go ahead, and the next thing says to take a ruler and measure the lengths of each side of the quadrilateral. So we're going to measure BF, FC, CG, and BG. So go ahead and measure those again, centimeters. Okay, I got about 3.5 centimeters. And again, you could be a little bit different than what I have. The key thing is that hopefully they're all pretty close to the same. Okay. All right, so we know that all sides, I'm not going to write them all out in format, but all sides are equal. Or congruent, either way you want to talk about it. Okay. All right, and then they ask you to use a protractor. I'm not going to make you go through and use a protractor and all that, but this one is about 125 degrees. This one over here is about 55 degrees, 125, and 55 degrees. So what do we know about the interior angles? Well, we know that opposite angles are congruent. Okay. We know that there are no 90-degree angles in here. So again, already the minute that we have the interior angles not being 90, we know that rules out square and square and rectangle. Okay. All right. Now, but we do have all equal sides. So kind of was thinking square, but now that we don't have 90, it looks like we're heading down the road of a rhombus. Okay. All right. And not all four are congruent, but we have that supplementary or consecutive angles are supplementary. So again, remember supplementary adding to 180. Okay, so, and I'll just do one here. So angle B plus angle F is equal to 180. And then it could just continue on F plus C, C plus G, G plus B. Okay, all right, so okay. Now, we do know, again, because we have the same qualities, basically, of what we just did with a parallelogram, we could call this a parallelogram, but because we do have opposite sides that are equal, so this part right here, we know that that makes us take it out of being a parallelogram and being more specific into being a rhombus. Okay, but you can still call it a parallelogram. That's just more general. And this one is specific. And it's more specific because of the fact that we have those all sides are equal. So for a rhombus, we know that opposite sides are congruent, consecutive angles, or opposite sides are congruent. All sides are equal, actually. Opposite angles are congruent. Consecutive angles are supplementary. And what do we know about their diagonals? Because FG and BC are the diagonals of this. Well, we know that the diagonals are perpendicular in a rhombus, okay, and not equal. So a rhombus has a lot of the same qualities that a parallelogram has, but it has some more specifics. It has all sides are equal, its diagonals are perpendicular, all right? A parallelogram also has diagonals that are not equal, but their diagonals are not perpendicular to each other. Here we know the diagonals in a rhombus are perpendicular, all right? And all sides are equal. So it's more specific than a parallelogram. You can call it a parallelogram, but more specific, it is a rhombus. All right. All right. Let's go on to the next page. So we're now on page 131. Okay. All right, so again, they ask us to use BC and move it to draw point H where the perpendicular bisector. So basically, they're asking us again to just with a patty paper, but they've already drawn it in here. So we're just going to label this part H right there on the inner circle. Okay, and we're going to label this part right here J, where that perpendicular bisector cuts in there with BC. Okay, so where the perpendicular bisector, so point J is where it intersects the outer circle, point H is where it intersects the inner circle. And again, they're going to ask us to connect the endpoints. So let's connect the endpoints. So B to H, H to C, C to J, and J to B. Okay, so what do we know about BC and HJ? Well, first off, we know that BC and HJ are diagonals of the quadrilateral BHCJ. Okay, so we know they're diagonals. We know again that BC is perpendicular to HJ. Okay. We know that BC is not equal to HJ. Okay. So again, we're kind of looking at a new type of thing. It kind of looks like a follows in suit with a rhombus because we have perpendicular and not equal, but now it's time to measure, and you can probably already guess that the lengths are going to be a little bit different. So go ahead and measure the outside lengths of the quadrilateral BH, HC, CJ, and BJ. Okay, so I got 3.5 centimeters, 3.5 centimeters, 4.5, and again, you can be a little bit different if on your measurements, that's fine. So in essence, this one is congruent to this, and this one is congruent to this one here. Okay. All right, so we notice that we have not, so it kind of rules it out as a rhombus, so not 4 equal sides, but we do have some equal sides. So not 4 equal sides, but we do have BH that is equal to HC and CJ that's equal to JB. So what this says is that consecutive sides are equal. Okay. All right, so we have consecutive sides that are equal, meaning sides that come right up next to each other. So BH and HC share a vertex point. JB and JC share a vertex point. Yes, JB and BH are also consecutive, but they are not equal. So JB and JC are equal, BH and HC are equal. So we have two sets of consecutive congruent sides. Okay. Now the angles, I'll just go ahead and give them to you. So we have 125 degrees up here. We have 75 degrees here. We have 90 degrees here. And this is just how this one is built. Not all of these turn out this way. So with a 90-degree angle in them. So if you notice, you don't have the consecutive angles are supplementary in this one, but you do have one set of opposite angles that are congruent. Okay, so the 75, so angle B and angle C are congruent, but H and J are not congruent. And this is just how this one is built, that J has a 90 degrees, so this quadrilateral doesn't always have a 90 degree or doesn't have to have. All right, so in this one, consecutive angles, whoops, I can't spell. So consecutive angles are not supplementary. Okay. One set of opposite angles are congruent or equal. Okay. Congruent, I can't spell. And that looks like an E now. So we will just make this into supplementary, are equal. Otherwise known as congruent. Okay. All right, so this one, they kind of give it away at the bottom here. It's called the kite. Okay, you guys usually are in elementary, they always call them a diamond, which is something that makes us upset. But okay, a kite's a quadrilateral with two pairs of equal, adjacent, or consecutive sides. The diagonals are perpendicular, non-congruent, and only one bisects each other. So these are all the things that are a little bit different about a kite. All right, so the diagonals are perpendicular, non-congruent, and only one bisects each other. And to be able to say it, it's a quadrilateral with two pairs of congruent or equal adjacent sides. And it kind of looks like a kite that you used to fly and that sort of thing. So where they're talking about the bisecting of the diagonals, so again, we're talking about that BC and HJ are the diagonals. So we know that BC is a diameter, so we know that this distance is equal, and I should use 3 lines there. So we know that that distance AB is equal to AC because they're radii, but AH is the radii of the smaller circle, where AJ is the radii of the larger circle. Okay, so, and again, not always will AB, AC, and AJ be equal to each other. It's just in how they constructed or drew this one. Okay, all right, now on to our next one. Okay. Oops. This is where we were going to start and that sort of thing, but okay. All right, so now we are going to get a new one here, okay? Now it's going to have us construct a perpendicular bisector, so all of a sudden they give us a circle that doesn't have the pre-constructed perpendicular bisector, but instead of going through and drawing it, we're just going to do our best to do one. And oops, I want to get, yep, black. All right, so try and make it as perpendicular as you can. It doesn't have to be exactly perfect, but try and make it to where it is perpendicular, or at least goes through the center and appears to be perpendicular, so that you have that perpendicular part to it without having to go through a full construction. Okay. All right, now we need to draw one that is not perpendicular through it, a diagonal that is not perpendicular through it. So we are just going to, oops, keep it the same thing. So we're just going to draw one through here like this. Okay. And we are going to label this ST. Whoops, wrong way to label ST. Label S and T. There we go. Okay, so we're going to label that ST. And we are going to connect the endpoints here. So we're going to connect Q to S with a line, not a... So do that with a straight edge, please. I thought I hit the right thing. Go. So QS, connect SR, RT, and QT. So you're going to connect those. So now we have QSRT, quadrilateral. And what do we know about QR and ST? Well, they're both diameters of the larger circle. There is no inner circle here. So we know that QR and ST are equal to each other because they're both the diameters. Okay? And we know, because we kind of drew in the perpendicular, that they are not perpendicular to each other. Okay? So we know that they're equal to each other. We know that they are not perpendicular. They are, again, the diagonals. So QR and ST are the diagonals of the quadrilateral that we just made. Okay. All right, now again, they ask us to measure the sides, so go ahead and take your ruler and measure the sides, QS, SR, RT, and QT. Okay, again, in centimeters, I got this side to be about 5.5, this side to be about 2.5, 5.5, and 2.5. Now, yours can be way different depending on where you drew ST. If you drew it somewhere close to where my ST is, then you should get something close. But if you drew your ST more towards the perpendicular or less towards the perpendicular, then you're going to get different side lengths. Okay. Right, so anyway, whichever way you go about doing it, you see that you have opposite sides that are equal here. Okay, so again, we have opposite sides are equal. Okay. But again, not all sides, all four sides are equal. Okay, so rules out that whole rhombus and square, goes back. We've already done a parallelogram, so now this probably leaves us to a rectangle situation. So we now have to go through and measure the angles. Well, I'll go ahead and save you that a little bit. So we know that this is a 90-degree angle here. We know this is a 90-degree angle here. This one is 90 degree, and this one is 90 degree. So we know that they're all 90 degrees for angles. Okay. So we have all four angles are 90-degree angles. Okay. So we can, this does go down the road of being called a parallelogram, but more specifically, it falls into a rectangle because of the 490 degrees. So we have rectangle, that is the specific, because of that 490 degrees. Okay. But it can be called a parallelogram as well. Again, that's more general. Okay, so it has the same properties as a parallelogram, just with a rectangle, it becomes more specific. So the other thing, all right, is that the diagonals bisect each other, just like in a parallelogram. So don't forget about that. But the key thing here is that, okay, the diagonals, and it kind of falls off of this one, the diagonals are equal. So if you know you have 4 90-degree angles, but opposite sides are not equal, then you have that rectangle, and therefore you know that the diagonals are equal. Okay, so you got diagonals are equal, opposite sides are equal, all 4 angles are 90 degrees. Okay, so falls into that whole rectangle. Okay. All right, one last one. You probably can guess what we're going to end up making because it's the last one that we haven't touched on yet, or at least of the special ones. We're not going to talk about trapezoids so much today. All right, this is where you actually need to take your compass and construct a circle. So finally, we are going to, whoops, come on. Maybe, if I can get it to work for me. There we go. All right, let's get rid of this one. Delete that, and let's get rid of this. Okay, so we need to construct a circle over here. Just make it big enough to where you can draw in it and write some stuff, but it doesn't have to be so big that it goes off or infringes on the whole drawing of the paper. So you just have to construct a circle around. Okay, I'm going to go ahead and label my point, my center here. Okay, now I can get rid of this. There we go. All right, so we have our center, our circle with its point of a center. Now we need to draw 2 basically perpendicular lines. So again, we're not going to get into construction and that sort of stuff. We're just going to do our best to make sure they look about as perpendicular to each other. So we're just going to draw them like a compass, north, south, east, west across here. And get that. Okay. They want us to label them, so we're going to label one VW, the other one QR. And yes, we didn't actually construct, but we're going to say that they are perpendicular to each other. Okay. Because of the fact that, so we'll just go ahead and get in here, QR and VW are perpendicular to each other. We know that QR and VW are congruent to each other because they're diameters. These are all things that we've been talking about. Okay. We know that QR bisects VW because of the fact that they are all radii out of the center. So whatever you want to call the center point, that center to Q, center to V, center to R, center to W are all radii. So therefore they bisect each other. And we need to connect. Forgot to connect our endpoints. Jumped ahead. So we're going to connect our endpoints here, Q to V, because we got to measure them. V to R, R to W, and W to Q. Okay. So go ahead and measure them. Oops. All I'm writing is that they're diagonals. Okay. And again, I got about 4 centimeters here, 4 centimeters here, 4 centimeters here, and 4 centimeters here. Okay. So we have all 4 equal sides. Okay. And if you take a protractor, you will find that this is a 90 degree, this is a 90 degree, this is a 90 degree, this is a 90 degree. So all 4 90-degree angles. All right, so what names can we use for this thing? Well, more commonly we call it, or more specifically, we call it a square. But it could also be a rectangle. It has all the properties of a rectangle. It has 4 90 degrees. That's all you need for a rectangle, is to have 4 90 degrees. For a rhombus, you got to have 4 equal sides. So basically a rhombus and a rectangle together make a square. Okay, so let's just kind of think about this a little bit. We know this is a square, the most specific. But it could also be called a rhombus. Could be called a rectangle, because it has all the same properties of this. Rhombus, rectangles, and then a parallelogram. The things that make it unique here as a square, or more specific as a square, again, especially with the properties of the diagonals, is that they're perpendicular, congruent, and bisect. All 3 of those things go on, whereas only in a rhombus do they equal each other, or bisect in the parallelogram, and then perpendicular in the rectangle. So there's all sorts of things that each property brings to a square. So if we were going to look at this kind of like in a big picture sort of thing, kind of everything falls under being a parallelogram, because a parallelogram, all you need is 2 parallel sides, 2 sets of parallel sides. Then from a parallelogram can come a rhombus. All you need for a rhombus is 4 equal sides. All the properties that come from that are great, but to say that something is a rhombus, you just need 4 equal sides. Then you also have a rectangle. That can be called a parallelogram, but for a rectangle, all you need is 4 90-degree angles. Now, a rectangle has parallel sides, so that's why it can be called a parallelogram, but if you know you have 4 90-degree angles, you have a rectangle. And then comes down here, these 2, rhombus and rectangle, together make a square. Okay? Where it has all the properties of a rhombus, all the properties of a rectangle, all the properties of a parallelogram. So 4 equal sides, or 4 90-degree angles, and 4 equal sides. Now, how does a kite come in here? Well, a kite kind of comes off of on its own little side, as well as with a trapezoid. So over here is kind of kites. And then you have a trapezoid. They're kind of their own little unique little side things over here. Because a kite does have some properties of a rhombus, but it's not, doesn't have the 4 equal sides that make it, and it doesn't have parallel sides that pulls it into the parallelogram. A trapezoid has exactly one set of parallel sides, so it does have kind of, whoops, exactly one set, there we go, of parallel sides. But it doesn't fall under the 2 sets of parallel sides. So they're kind of their own little side thing. They are quadrilaterals. They have some unique properties that they kind of share with either a rhombus or rectangle parallelogram, but they don't fall quite underneath it. Okay. Again, sorry, these are a little bit longer of notes, a lot of information, a lot of definitions and that sort of thing. So your homework tonight is building off of this concept of quadrilaterals.